already run the code and also connecting with my email address, which email I already use in my opening the Google Earth Engine account. Okay, just simply allow on my Google Earth Engine account, then it will be okay. Further, I simply mention here, you can see the ee.initialize project Mijan GE. So basically this is my project name, so you can easily find out your own project name in here. You can see it show you the project name. Okay, so this name simply
Yes.
write in here as the project name, then run the code, then it will say okay, there is no problem. So now further it also writes some comment, basically what is the species distribution modeling. So basically species distribution modeling is the most common method used to estimate the actual or potential geographic distribution of a species. Okay, and it involves the characterizing the environmental conditions suitable for a particular species, and then identifying the distribution, identifying where this suitable condition are distributed geographically. Okay, so SDM, so it's one kind of model. We are just use this method, and further we can easily estimate the actual or potential geographic distribution any species. Okay, in this time we are just need the species occurrence data, so it can be any kinds of species we can easily do, and it mainly work for find out the suitable place for a specific species, and further it also used to predict the suitable condition for a specific species. Okay. And in Google Earth Engine basically we can easily find out all of large scale environmental data, so we can easily get all of data from Google Earth Engine. So that's why you can easily implementing the species distribution model in Google Earth Engine. So now what types of data we need? Okay, so basically in this case we need the two types of data are required when you work with SDM, mainly species distribution modeling. We need two types of model. So first data basically occurrence record of non species. Okay, suppose if you know where the species, how many times, it's occurrence data record. Suppose I have total I have suppose for this bird, basically this type of bird, where it will be migrant. Okay, or where it will migrant, this type of place data we need, or ground truth data. So this type of ground truth data, so in this time suppose this bird we can find out for a specific country, and suppose we can see here basically it also show this type of information, also range map. Suppose this type of place we find out this type of uh, bird. Okay, so it's the occurrence data. Okay, suppose this type of place we find out the bird, so it's one kind of occurrence data. So this data we need when you work with the specific species distribution modeling for any species. So in this case we just,
Sir, sorry.
yeah please, yeah.
Where are these codes downloaded?
Okay, okay, I will send you this code, you can easily get it, no problem. I will send you this full code. Further you also try to work with that, no problem.
Uh, so you are recording is it
Yeah, I also recorded
a
with you.
video?
Yeah, no problem.
Because now I today I see it is out of the class link. That's why I've asked. Thank
Yeah,
you. Continue.
yeah. Okay, so now we find out the occurrence data. So in this case we need the occurrence record for non-species. So which space you want to make the classification, or you want to identify. Okay, so then we need the occurrence record of non-species, and also various environmental variables. So different types of environmental variable. So it can be suppose temperature, then suppose wind speed, or precipitation, rainfall, different types of environmental variable we need. So when you do any kinds of species distribution modeling, first of all we need the occurrence data. The occurrence data mainly how much where this type of bird migrant. Okay, where it come from, so this type of data mainly a specific geolocation, this type of data. And secondly we need the different types of environmental variable, different types of environmental variable we need. And now what is the workflow? If you check the workflow, basically first of all we need to collection and pre-processing of species occurrence data. So this is the first step, which species you want, just simply collect the species data, and then collection or pre-processing this type of data for occurrence data we also did, and then further definition of the area of interest, basically which area you want to work for that. So simply define your study area. After that, we need to just addition of GE environmental variable, so different types of environmental variable you need to add, and generation of the pseudo absence data, and model fitting the prediction, and variable importance and accuracy assessment for checking the accuracy of our prediction. So basically SDM model is also help you to identify where the suitable place for different types of species we can also predict using this model. So now here you can see habitat prediction analyzing using Google Earth Engine. So in this case here you can see the Peripita. So basically this type of bird, it's called the Peripita. So this bird will be used as a case study, demonstrate the application of the Google Earth Engine SDM. And while the specific species has been selected one example, you can easily method for any target species you can do, and you can also modify this code, the source code, you also modify this code easily. And fairy pita is rare in the summer migrant, and passes the migrant in the South Korea. Okay, so this type of map, you if you check, we find out the from here. So this type of South Korea you can see. So this type of place is that one kind of occurrence place about that, this type of fairy pita. Okay, also this type of place Taiwan. Okay, but mostly we find out the South Korea region, this type of part. Okay, so it's one kind. Okay, find out from here. And then conducting the SDM model, conserve the planning for the fairy pita appears to quite okay. They are also use this type of things. So now how I can work with that. So first of all, here you can see just import some different types of library, such as GE map, color maps as CM. Okay, pandas mainly PD, geopandas, GPD, then NumPy, matplotlib, pyplot. Okay, all of necessary like ipyleaflet. So this type of necessary library simply import and run it. Okay, I done that again. Okay, there is no problem. So now we just need to collection and pre-processing the species occurrence data. Okay, for this. So this is the first. So in this case, basically let's collect the occurrence data for the fairy pita bird. Even if you don't currently have access to occurrence data for the species or to interest, you can obtain the observational data about the specific species through this the link about that. So you can easily you can see this page. Okay, just simply click on here. So basically from here they also take the data. An interface allow access to the species distribution data provided by GBIF, enabling users to search, filter, and download the data as well as acquire various information related to this space. So we can simply find out the search and filter data from here. Suppose simply search here for data processing, series. Occurrence clustering. Okay, so free and open access to biodiversity data we can also get from here. So this is the link about that. gbi.org. So from here you can easily find out the occurrence, species, dataset, publishers, resources, free and open access to biodiversity data. We can easily find out from here. Okay, and GBIF basically it is a global biodiversity information facility. We can easily find out the data infrastructure funded by the world's governments and the M2. Okay, so from I can easily find out, I think, different types of data. Suppose occurrence data in it.
Sir,
Yeah, please.
I'm sorry, 1 minute. Sorry, sir.
Okay, no problem. You can take the time.
Okay, thank you. Sir,
Yes, please. Yeah. Okay.
sorry, I'm back.
Okay, continue. Okay, so basically there in this time, in the code, they also write this type of things if you check. So this is the one kind of API, mainly from this API that allow access to the species distribution data provided by GBIF. So we can easily find out this data from the API. We don't need to download from this website. So from this website, it directly connect with the using the API, and from here we can easily get the data. So in the code below, a species name, you can see the species name variable is assigned the scientific name of the species. So for the fairy pita, this is a scientific name about this specific species. Okay, so pita nympha. So this is a scientific name. So a species name. So for the species name, we just write here this scientific name. Okay, and the country code. Country code mainly your country area variable is assigned by the country code South Korea, because in this time we find out for the South Korea. And base URL, basically this base URL variable stored the address of the GPI API. So it stored the API. So in this time, we need this type of things. Here you can see scientific name, basically your species scientific name. We need the country code, limit the search to the specific country. Okay, and then we need that hash coordinate, basically ensure the only data will be coordinate truly available. Then basis of record, choose only the record the human observation or a human observation, and limit. So now in this case here you can see it just create a function. Like you can see we define the def, it's the function, then define the variable name, function variable name, and we put the two element. First element is the species name, second element is the country code. So now it create, you can see this is the mainly API. Basically you can see this is the API, basically occurrence. Okay, occurrence API. And then further you can see the scientific name. Okay, put the species name, then country code, put the country code. Basically I put here the species name, that's why I put the species name in here. So it's one kind of function. So in this function, if you check the in this function, we are just call the function variable name. So this is the function variable name I just call, and then mention here the scientific name, and also mention here the country code of South Korea, mainly KR. This is a scientific code. Okay, so now further, okay, so first of all it's very important when you work with this data from the GBIF. This is the data, it provides the occurrence data. So then we are just use the same code all time. Okay, same code we try to all time we try to use in here. A species name and country code we need to define. Okay, suppose further also check this type of website, which type of data we find out. You can see from here you can get the animalia or different types of species we can easily find out. You can see the distributed for the whole world. You can see the kingdom. Okay, you can see the phylum. Okay, different types of things you can see for a specific location. You find out the different types of things. You can see the fungi classification, fungi. So different types of things we can easily find out from here. Okay, in also search the others. Okay, just click on, then you can find the others. Okay, the different types of species. Okay, and their locational, we find out the geographical location. So it's one kind of data, but in this case we need that suppose occurrence. Just click on the occurrence. So now it open all of species occurrence. Okay, so from here just we copy the occurrence API, basically this link you can see. Okay, occurrence API, so it's one kind of API. So now here you can write any species name. any species name. Basically this name you need to write in here in the call the function variable name and write the species name and put the country name, then it easily loaded. Okay, this data easily loaded as a data frame. Okay, in the data frame we can easily find out, we can see this type of information, we can easily find out in here. It's one kind of data frame, we can easily find out from this API. Basically this is the API link. Okay, we create a function, you can see just, I think it will open. Oh, yeah, so here you can see, so here you can see different types of data we can find out from here. You can see the scientific name. Okay, this is a column of scientific name. So here we find out the all of scientific name. Mainly we find out that uh a specific occurrence. Okay, this time we can see the Australia, Denmark, so different types of, we can see different types of species. It's a scientific name. Or you can simply search the Google, then you also get the all of details about the species easily. You can easily find out from here. For any specific species, you can easily find out from here. Okay, and okay, and when you are using this API, if we check it, I think we need to log in. You can see the login button also available. Suppose I want to work for this spaces, just click, you can see the occurrence, just click on here. So now here you can see, find out this type of information. So this is the one kind of uh mammalia, you can say the animalia. This is the different types of face. Okay, we find out that. So this website is very important for that geology. Okay, or species distribution, it's very important. From you can find out lot of data. Okay, so this is the, against the fail list, so I simply search and check what is that. Simply search on the Google, then you also get easily get all of details about that. So yeah, so it's one kind of cat, I think. So Phyllis cat, catus. Okay, so this type of species where we find out that distribution. Okay, we can easily find out. So this is the data about that. For this specific, we can find out this place. And now further these things we need to, suppose I want to check that specifics and further return to predict. Okay, so for the prediction where this type of species is more suitable, so this type of things we can easily find out in this code. So now I think we need to, you can see here content, we need to just log in. Okay, just click on the login and then check what happened. Okay, so if you done any account, just simply click on the set. Okay, gbif data, we can easily find out. So in this case you can see this is the occurrence. So in this time simply put the species name and country code. So any species name we can easily search from here. Suppose just simply put here that species name and also put the country code, and further we can easily run the code. Okay, just run the code, and further you can see just run the code. So now using the parameter set previously, you get the AQI key and load the result data frame. You can find out that this type of data frame, you can see this is the key, then we can find out all of information. So now it work as a data frame. So now this data frame convert the geodata frame. Okay, so now this is the data frame, this data frame convert to the geodata frame. Geodata frame basically it's including the latitude longitude value, and also you can see it's about that your projection, mainly coordinate reference system. So just we try to run the code. So now it convert as a geodata frame. You can see here we find out, you can see a species name is that Pita Namphua. This is a scientific name. Year 2024, month mainly 6. Okay, and point. So this is the point. Okay, so this is the data. Okay, basically this is the data. Okay, and further we try to plot this type of data. You can see the year and monthly data distribution heat map. We try to create a heat map. So this heat map represent the result. Okay, how much time we find out this species for this specific location. So now, yeah, please,
Sorry.
yeah, please.
Heat map, what does it mean? Because it is not a new word today to hear. Heat map. What does heat map means exactly?
Heat map
Is it?
basically it just show you the, suppose where I find out the high occurrence. Suppose for this place I find out that lot of time I find out this type of species, so it look very high value. Okay, where I find out the low time, it show the low value. Okay, so this heat map is just not for the temperature like that, it just show you that suppose where I find out the high occurrence of this species, it show as a high value. Okay, it show the high density value of this of the distribution. Where find out the low value, it show the low distribution. Okay,
Something like a trend analysis.
yes. Suppose
Okay,
this
okay.
place is very high, so it show very. Okay, let me check the map. So now I can see we find out this type of okay, so let me plot this heat map. So now we find out, you can see which time we find out that. So it's just show one kind of calendar. You can see the monthly spaces count by year, and this is the month and this is the year. So here you can see basically find out this time. Okay, 35 count. We count the 35 in this month. And what is the month? This month is mainly for 6. And what is the year? This year for 2021. And you can see we find out the 55. Okay, same month is the 6 and 2023. So basically in this time, so this time if you check, so basically 55, it show the it count, this occurrence is very high in this time 2000 2023. We find out that 55 times in mainly this month of January, February, March, April, May, June, month of June, we find out that. Okay, this type of species. Okay, so now you can see it is the count mainly how much time. So here you can see we find out the one time, two time, this type of time period. You can see this type of time period to show this type of things. You can see the month. Okay, this type of month there is no, or only for the two you can see this month. Okay, with this type of month finding here also you can see. So now basically this map it show you that for this distribution. Okay, heat map basically yearly and monthly data distribution for this specific species. Okay, so for that you can see they write the code. Basically they create a function. You can see plot heat map, put the function variable name, and they are used at the GDF basically it the GeoPandas library. Okay, just create the GDF, and then put at the size equal to 8, and then put at the month and year size. There calculate the count the number. Suppose each month, each year, suppose month of June how much, month of July how much, they calculate the size and unstack all of value just which have equal to 0. Suppose just unstack this type of things, just remove. Okay, and further they are plot this size, and they are create the heat map. So for the heat map they are called the matplotlib, mainly PLT, and IM show. This is one kind of function. So now put here the CMap color and origin, and this type of thing they are put in here. So now this create a function. Okay, just it create a function. So further they are called this function variable name. Okay, plot heat map. Just further put at the level count or other simply add in here. So now we can easily find out. You can see calendar wise. Suppose we find out the this time, basically June 2023, show the very high 22, 35, 20, 55. So we find out the highest value, highest count, how highest occurrence. We find out the 55 from this data which I downloaded from GBIF website. Basically this website we simply connecting and downloading from here. So now you can see the observation. So the data from 1955 is very sparse, and further with the significant gaps. Okay, compared to the other years, and the month of August and September also have the limited sample and exhibit the different seasonal characteristic compared to the other period. Excluding the data could contribute to improving the stability and predictive power of the model. Okay, so here the importance note that excluding data maybe enhance the model's generalization ability, but it could also lead to the loss of valuable information relevant to the research objective. Therefore such decision should be made with the careful consideration. Okay, when you just set your time period. Okay, so now further it filtering the date by year and month. So just run the code. Now the filtered geodata is the converted to the Google Earth Engine object. So for the converting Google Earth Engine object, just use the function. This function mainly convert the geodata frame to the Earth Engine object, because further we also use it in the Google Earth Engine. So that's why these things we need to convert it. Okay, convert. So now we'll work with the raster pixel size of the SDM result, 1 kilometer resolution. So that's why we are just put here this grain size, mainly spatial resolution setting 1000 meter. We simply set it, and then we multiple occurrence point are present in the same 1 kilometer resolution raster pixel, and there the high likelihood that they share the same environmental condition at the same geographic location. So now we are just try to plot this type of things, mainly this type of occurrence data on our map. We try to plot. So we find out, you can see the data size 259. Okay, and from here we selection, and after selection we find out that 144 final 144 data. So now this data we try to visualize. This data simply visualize in our map, mainly as a point. So if you check it, edit, basically this type of things we find out, this type of occurrence. Okay, occurrence, basically this type of data we find out in here. Okay, so basically this type of place we find out this type of spaces, and you can see what is the suppose this one point, suppose this one point, what is the cell size 1000 meter. We consider 1000 meter, this cell size we put the 1000 meter. So now you can see in South Korea, this place, this type of data we find out. Okay, so now this data how I generate, it's very important. Basically this data we generate from this information where we find out the data, this type of from here. Okay, from here we just connect our data. So now first of all when you work, so you also try to adapt this type of code for your own data. Okay, so basically this type of point we generate from our from this data. Okay, we generate from this data, this type of geolocation we find out from this data. Okay, so okay, so now if I just again explain this code, you can see here. So first of all we just simply import all of necessary library which I need. We just simply import, and further we are just need the data. So basically biodiversity data or species occurrence, different types of species data we can get from this gbif.org. So in this case, this is it create a function. Okay, in this function we can simply just call the scientific name, scientific name of a species. Suppose peter number, it's one kind of scientific name, and then which country I need this data, suppose South Korea. So put here the ISO code KR. So now this data save as a, you can see as a data frame. Okay, it's saved as a data frame. So this data further we convert as a geodata frame. Okay, geodata frame mainly we need to add the latitude and longitude value. Okay, and further we can find out, you can see this type of things. Now it work as a geodata frame. When I add, we find out that geodata frame from here. Okay, so we find out this type of things as a geodata frame. And after doing these things, just we try to check, suppose fill yearly and monthly data distribution heat map. Okay, suppose which year, which month I find out the high count of occurrence. So for that we are just use the code, and then we can easily find out this type of month. We find out that high occurrence of the data of this species for this time. And then we try to add here, you can see the filtering year and by months and data row. So now this is the function geopandas to EE. This function mainly convert as the Earth Engine object, because further we try to add it in the Earth Engine. So now we will define the raster pixel size of the SDM result as a 1 kilometer resolution. So just put here the 1. So now just try to add all of data in our map. Okay, so then we try to add all of data and also add the cell size. If you zoom, then we also find out the cell size. You can see this type of cell, it show this type of cell, and one cell size is that 1000 meter pixel size. Okay, it create. So now after doing this thing, now we need to define the area of interest. So which area you want to work, just simply intersect with that. So now define the area of interest. Just we try to use here, you can see, just we define the data, geometry, bounds, and put the buffer region. We take that, you can see 15,000 buffer region consider. Okay, and further just run the code. So now it create, you can see this type of region. So but in this time I just work only for this place. So this is my region of interest. Okay, and this is my point, this type of point. We find out that this is the occurrence data. Okay, so now we just take that occurrence data for the fairy pita, this bird. But further you can easily use any kinds of data. Okay, any kinds of species for a specific species. Okay, and all of specific species information you can easily get from here. Okay, so you can see the different types of data download. So occurrence data download format, so different types of things you can easily get from here. And further you can also use it, this type of, you can see this is the one kind of occurrence. Also you can see, so different types of species data we can easily find out from here, and then also use it. So further you just need to sign in with this website, then you can easily get it all of information from here. Okay, so now we define our study area. So now we try to, let's add the environmental variable. So different types of environmental variable we try to add in here. So now we try to add here, suppose temperature, precipitation, elevation, land cover, terrain. Basically this type of environmental variable is also affected, also work for that suitability for different types of species. Okay, so in this case if you check the dataset, enable us to the comprehensively analyze various factors that may influence the habitat preference for the fairy pita. Basically this type of factor such as temperature, precipitation, elevation, land cover, terrain, this type of data mainly influence the habitat preference for the different types of species. Okay, so that's why we try to use this type of data. So in this case we try to use here the world bioclimate data. Okay, world bioclimate data, this data provide the 19 bioclimatic variable. Okay, world bioclimate data, it provides the total 19 bioclimatic variable derived from the monthly temperature and precipitation data. It covers the period from this, you can say, very long time period. We find out the data. So just I simply call the data set world bioclimate, as well as we also call the NASA SRTM data, mainly elevation, and also call that global forest covered change data. Okay, we also call this data. So this type of data is easily available in the Google Earth Engine data catalog. Okay, just we simply call this type of data, as well as bioclimatic variable, terrain for topography, median TC military canopy cover, and also elevation from terrain, watermarks. Okay, so just we try to put, you can see, combine the bands into the multi-band. Okay, so just bio add bands with terrain, just we just simply combine. Okay, and create a watermarks. So for that we are just terrain, select elevation greater than 0, greater than 0, all of things, just watermarks, mainly remove all of water, and also max out the ocean pixel, clip the area of interest. So just we predict unmax the watermarks and clip with the study area. So further run the code, and further it show that when highly correlated predictor variables are included together in a model, so we need to issue again arrays such as multicollinearity is phenomena that occurs that a strong linear relationship among the independent variable in a model. So for that we will generate the 5,000 random points. Okay, 5,000 random points, and then extract the predictor variable values, the single multiband images. So now we create the 5,000 random point. Okay, and then we extract the pixel value using the sample region function from this data. You can see from this data correlation it find out from here. So from here, so now try to extract the predictor pixel value, and further convert the predictor pixel value from the Earth engine to data frame. So just E to data frame we try to put it, you can see it show you that all of value Okay, this is my predictor value. So this type of predictor value we are used, and further we just predict for the suitable region. So then display the columns, just show the columns, you can see find out in here. And now calculating the Spokesman correlation coefficient between the variable and visualization the heat map. So try to add the heat map again. So now if you check it, just plot it, correlation heat map analysis. So now we find out, you can see this type of correlation heat map at a same time all of predicted variability. So we can easily find out, we can see. So Spokesman's correlation, you can see basically this type of red color indicating about the high correlation. This type of blue color we find out the low correlation. So if you check it, you can see the slope. Also you can see then hillshade, elevation. Then you can see that bio 19. So this type of things have the high correlation we find out in here. Okay, if you check suppose these things, basically it show the slope and elevation. Okay, also you can see this type, so this type of blue color you can see mainly, you can see this thing mainly bio 15 and this the bio 16, very correlation we find out for this. Okay, basically this time this chart represent the correlation for each, suppose slope to slope, slope to hillshade, slope to slope and elevation. Okay, so just we create the heat map and also represent the correlation between the two parameter, between the two parameter. Okay, so it's one kind of correlation heat map we create in here. And further specimen correlation curve is useful to understanding the general association among the predicted variable, does not directly assess the how multiple variable interact, especially detecting the multicollinearity we also find out from here, and also the variance inflation factor. Okay, we check also from here. So now filter the variable based on the variance inflation error, we try to just filter and then remove. So now where I find out that low correlation, just remove all of things from here, inflation value just simply remove from here. And now show the again, we try to just keep only for those, you can see TCC, aspect, bio 14, elevation, slope. So basically this type of variable it give me the high correlation. Okay, but others in this time you can see just like removing this type of bio 5, 4, 10. So it's one kind of information. Okay, different types of information. So this type of things is not much important for my model in this time. So that's why I just simply remove all of those and just keep only for those, you can see just keep only for this parameter TCC, mainly tree cover, then aspect bio 09, bio 15, 14, elevation, slope. So this 6 parameter is very essential for my model. Okay, so that's why I just keep only for those, and further you can see it just display this type of thing we try to display. Okay, let me try to run this type of things. Okay, just run the code, we just create a legend. So now we try to display the elevation map, you can see. So now it create the elevation map, we just work it as a predicted variable or environmental variable, and then you can see the calculate the minimum and maximum value for bio 9 and also create the map. It just create the map for the bio 09. Okay, we find out this type of map, mainly mean temperature we find out in here, also slope. Okay, just run the code, we just find out the slope. Okay, you can see the slope, and further you can see the aspect, it also calculate the aspect. And we find out the aspect, and then you can see calculate the bio 14. Okay, also add the bio 14 map. Bio 14 basically it's the precipitation of the desired month, and further tree canopy cover. Okay, so it's the tree canopy cover map for our study area. So it's a environmental factor which we are used for predicting the suitable habitat for the pretty uh, fairy pretty bird. Okay, and general pseudo absence data. Okay, so just we try to randomly just use, and presence location max, and also add the map. So this is our present location. And now we try to apply the fitting and prediction. So there also add all of theoretical part. Further also read it. So now it creation of the special block. Okay, just we try to just create this type of block. Okay, so now we can fit the model, and fitting a model involves with understanding the pattern, the data, and adjusting the model parameter. So now we will just apply here random forest. Just apply random forest, apply in here, and then just spill the data and run it. So now further we try to visualize the map, habitat distribution and potential distribution map. You can see here habitat distribution and potential distribution map. The habitat suitability map is created by using mean function to calculate the average of for each pixel location across all images, and the potential distribution map is generated by using mode function to determine the most frequently occurring value at each pixel location. So you can see it create this two type of map. It's just a image. So further when you run the code, it easily added this map. Habitat map, and also you find out that habitat suitability. So you find out habitat suitability. It working, you can see. So basically this type of color, blue color, indicating about the high suitability place for the pretty bird. And this type of yellow color, it show the low suitability place for the yellow bird. And potential distribution map, just try to add. So now it's added that potential distribution map. So you find out this type of 0.5 to 1. It's a high potential distribution. We find out the pretty bird, and you can see it's a presence. Okay, so you can see the three lot ending here. So basically this type of red color, we find out this type of it's our ground truth data which we generate from this API. Okay, and this is the potential distribution. So 0.5 to 0.10, we find out this type of place, the potential distribution of pretty bird. And this one is for that suitability habitat for the pretty bird. Okay, this type of color indicating the high suitability place for the pretty bird. And further we try to check the accuracy and also check the importance. Basically random forest is one of the assemble learning method which operate the constructing multiple decision tree and make the just theoretical. Just run the code. So now we finally can see which one is very important for our model. We find out the tree is the very high importance, then elevation, then bio-40 aspect, bio-40 slope. So for our model, it's very important, this type of parameter. And very high important is the tree cover. So tree cover is very high influence to suitability of pretty bird. Then elevation, then bio, then aspect, then bio 09, then slope. Okay, so basically it show about the influence, which environmental factor is more influence to habitat of pretty bird. So TCC is the very high, mainly tree canopy cover, then elevation, then bio 14, then aspect, then bio 09, then slope. Okay, so this is the average variable importance we find out. And further, using the training data set, we calculate the ROC curve for the accuracy. Okay, so basically it's compute the average AOC and ROC curve over the iteration. So just try to run the code for checking the accuracy. They are just testing dataset create, and further it's just connecting with, you can see that this is the formula about that: total positive value plus false negative, TP plus FN, true positive and false negative. Again, let's run it. And then calculate and print the AOC metric, and further just run it. So now it create the iteration as well as also create for that value for each images, calculate for ROC curve. Okay, it calculating. Okay, so here you can see find out this type of value. Basically calculate the AUC and ROC and AUC and PR value for total 10 iteration, and further it calculated the mean. We find out the 0.7. Okay, and also find the 0.68. Okay, so it calculate the 70%. Okay, plus 1 minus plus minus 0.1. Okay, or 10%. Okay, so 80% increasing, or 60%. Okay, so this is the mean. We find out the accuracy. And basically this tutorial also again, so now this is the process. Okay, so how we can easily work. So this code is very long. Okay, so you also try to adapt the code for other species. Basically we can find out all of species data from this website. So from here you try to work for a specific species for your own country. Suppose your country have a specific species and you try to find out the potentiality map or potential map. Okay, then we can easily work with that. Suppose I will show that one example. Suppose I want to work for the another species. Okay, just click on the get data species, click on here. So you'll find out, you can see different types of species in here. So Animalia, accepted kingdom, this is the total occurrence. You can see Animalia, we find out in here. Okay, suppose I work for that Animalia, just I click on here. So this is my species name, kingdom. So this is the Animalia species. So you can see occurrence, this is the total occurrence time, and this you can see it's available for the worldwide. Suppose you want to work only for this specific country, it also possible. Just simply put the country code and work with that. Alright, you can see family. Click on the spaces. So here you can see different types of species we find out for this Animalia. So this is the one kind of, okay. Okay, so you can see different types of species and also show the distribution. You can see species distribution, let's find out in here. But suppose I want to check it for Royal Bengal, suppose tigers, scientific name. Okay, so Panthera tigris. So this is a scientific name of Royal Bengal tiger. I want to suppose find out this data. Panthera tigris. This is the name. So Panthera tigris we find out, yeah. So this we find out, you can see basically the Royal Bengal tiger we only find out for in Bangladesh mangrove forest and also some other part in India. This type of species, Panthera tigris, you can see just we find out in here in the Bangladesh mangrove forest, as well as we also find out some part in here. So you can see we find out all of those in here in the forest. Suppose I want to work for this mangrove forest or whole Bangladesh, we try to find out, or in specific you can see basically find out. So this is the mangrove forest area in Bangladesh. Okay, so this data I want to suppose work, and further we try to find out that potential distribution and also find out that this type of things. So let's go how I can easily work with that. So Panthera tigris, so this is my species name. Okay, so let's go try to work with for that Panthera tigris. Just I copy this Panthera tigris, and this Panthera tigris we try to just change in here. Just suppose all of those are the same, just I simply put here the species name as a Panthera tigris, just paste here and put here the country code. Okay, for the country code Bangladesh I put the whole country, suppose BG. Okay, so just run the code and then check what happened. it show that no data found for the given species and country code. Okay, so let me check for suppose India. Okay, so now we find out that I can see for that Panther tigris data we find out for this India. Okay, so now this species is open in here. So now same process, we just try to check for the tiger, for the suitability map of tiger and also distribution. So the same process, just run the code, convert it into geodata frame. So just we convert, you can see Panther tigris 2025 month of January. Okay, January, we just convert the geodata frame. So now further run the code. So now it yearly and we can find out, you can see. So basically just plot it again. So now we can see, find out this type of count. So basically in the, you can see 2024 we find out this type of place. Okay, how much time. Okay, we find out that 19 times in January, then 42 times in the February. Okay, so we can get the information by monthly and yearly distribution of the species. And further, in this case, you can see I just need the data. Suppose I need the data from January to suppose December. Okay, so all time we find out the data. So I put here month, suppose January to December. Basically which month you find out that more data. Okay, more frequency is very high. So in this case you can see almost we find out that high. Okay, so I take whole year, that was 12. Okay, January to December. And further just data and row.
Sir, sir,
Yeah, please.
you didn't change the year. You still
Oh, okay, so we put
leave
here
the
suppose, yeah, suppose, yeah, yes.
1995.
So we put here the year of 2024.
Yes, yes.
2024 because it this year for the high frequency. Okay, now
Yeah.
run the code. Okay, done. So now filtered the geodata frame is converted into Google Earth Engine. Same process, just convert. And now we take the grain size, suppose 1000. And further, we just remove. Okay, but it show that zero data size. There is no data. Okay, so let me try to add. Suppose. Okay, just try to put suppose 2023 and then check. Suppose I put here, suppose from, okay, just I try to put the very past year and then check what happened. That was 1985. Suppose in this time it just filter from 985, from all of January and December. Okay, all of month. Okay, it shows the zero data size. Yes, so now we find out, yeah. So I think this way is that we try to take that high count month, okay? So high frequency or high count month. Suppose in this case, you can see that January to May, May, yeah. We now try to put it suppose 2024. Now check the data.
Wani au ni vipi? Maana atuelewa. Maana kuna mtu mwingine unaona kuna afadhali test 1 afu test 2 umefeli. Unataka kufanya nini? Yaani tuelekeze basi hapo.
I set the zoom level. How will I put here that 90 and 23? Or coordinate, just put the coordinate of your study area. I think I'm going to show just a minute. We find out the original data and final data we just create, and now just define the area of interest. Just we okay, just run the code. So I can say find out these are study area. So in this case, we are just use here. You can see the study area 15,000 buffer distance we create. So you can easily create any distance from here, no problem. And further, just adding this type of data, mainly bioclimate data, train data, then global forest cover change data, and combine all of environmental predicted value. Then we generate the 5000 random point and extract the pixel value from here. Now it extract the pixel value. You can see all of predicted variables. So now display, and now we are just create the correlation. Okay, so we find this type of correlation, but in this case which is more important, just we take another, just remove filter based on the variance inflation factor. So now further we just calculate the removing. Okay, this type of things is that not much important for this. So now we keep only for those. We are just use this type of variable selection based on the VIF. So in this time you can see it added this type of things. So every species we find out the every new variable which is more important or which have more importance or correlation is very high. So in this case, again, the slope is very high correlation. Then slope and elevation, high elevation. We find out this type of things in here. So now we try to create this type of map for that or study area. So just create the level, then create the elevation map for our study area, because it's one kind of environmental variable. We'll just add, you can see it added this type of elevation. Then just calculate that minimum maximum value for bio 09. It's a problem. Bio 09 did not match any band. Okay, I think bio 09 we are just removed. Bio 09 is not need for that. So let me check for that which is the new one. So we find out, you can see bio 19. Okay, so we need the bio 14, bio 18, bio 19. Okay, so this type of factor in this time we are just working. Other invariant variable don't need. But previous time when I work with this bird, pretty bird, but for that we also need the bio. You can see we are just use the previous one, bio 0, but in this time I just change it. I put it, it's a bio 19. Suppose bio 19. No, not it. So now it's work, you can see. And now we add the map for bio 19. Put here bio 19. Bioclimatic variable bio 19. And run on it. Okay, now we can get that bio 19. And what is the bio 19? This type of information you can easily search on the Google. Suppose simply search here bioclimatic variable. Simply search. This is the dataset information bioclimatic. We can see bio 19 is the precipitation of the coldest quarter. Okay, so just you can write this type of things. Further, just copy the title and use it in here. So you can it show the a previous one title. Change it. So just put here. Run the code. Okay, so now you can see this type of things in here. Okay, so next you can see about that slope. Just on the code slope. Slope is also it. So basically, if you can just you can see this type of band we need to add. Okay, you can see this type of TCC aspect slope bio 6, all of those we need to add. Okay, Just try to add. Then aspect. We find out the aspect. Then bio 14. Okay, just try to check what happened. Bio 14. And precipitation. So we find out the precipitation. You can see it also added. Then tree canopy cover. It also added. You can see tree canopy cover map. And further, if you want, you also add the more other parameter which are available. Simply add the same process for others. Okay, in this case, I just keep the same. And further, just run the code. So now I can find out that max area. So now we just fitting with our modeling. Just run the code. So now it creates this type of block. Same code. Try to add for the different types of. Now spill the data. Now we calculate the habitat suitability map and potential suitability map. Okay, for the tigers. And further we try to add the map. Just run the code. So now it create that habitat suitability for the tigers. Okay, so see the legend. So basically we can easily find out that which place is more suitable. If you check it from here, this type of blue color, basically blue color indicating about that high suitability region, and then potential suitability distribution. Just add. So now it find out that potential suitability map. So here you can see. Okay, so you can see this area is not much suitable, potential suitable for the tigers. Okay, in this time we find out the, you can see white color, green color indicating about the suitable place, potential suitable place or potential distribution for this species. And further just check the accuracy and also check the importance factor. So for that, for this time you can see find out that bio 18 is very high importance for this species. And what is the bio 18? Check the bio 18 precipitation. Okay, in the warmest quarter is very important for the panthera tigris or tigers. Further, if you check the others, then bio 06, bio 14, bio 19, then elevation, aspect, tree cover, slope, Okay, so we find out the gradually this type of factor is importance for this specific distribution, and then further check the result for the accuracy and check it. Now it calculate the AOC and ROC curve value for each iteration.
Sir,
Yes, please.
is it possible to download those output
Okay.
and make a layout by using maybe
Yeah, it also
ArcGIS?
possible. Yeah. So for that, suppose the final output, this one I want to download. Suppose this map, habitat suitability, this map. So these things we can download it. Right here, same code, export image to drive, and further use the same code to export. In this case, you can see basically which layer. Basically, habitat suitability is that habitat suitability. This one, yeah, model average. So this variable is stored this map model average. Just try to connect in here. Suppose if I just copy, no export. Okay, export is not defined. Just a minute.
Those argument as a list, those argument as a dictionary. No need.
No need. It just show the. I think. Let me check. Just a minute. Okay. So when you export this type of TIFF file, we need to export the image to specify the. Okay, so let's go. Uh, just take a variable, suppose tax, and write here ee dot base dot export dot image to drive. Okay, this thing I write in here, and then image mainly our variable, which variable is stored this image, which variable, yeah, this one. Just copy and then paste here, and then second argument, suppose description for the description. Sorry, it's a equal, not the colon. For the Python, you have to use the equal. For the description, suppose habitat suitability. Then put the region, suppose What is the region? AOI. Okay, AOI. So now run the code. It's done. So further, just write here tags, call the variable name, and put here that start. Just run the code. So now it will be starting. You can see none. So how I can check it? Simply open your code editor and go to the tags tab. Yeah, so now it's working. Yeah, you can see working. So further format, just download it.
Sir,
Yeah, please.
you have connected your JavaScript Google engine with the Python.
Yes, yes. Basically, you can see when I just run these things in here, I already connecting with my email, which email I want to use, as well as I also connecting with my cloud project. First time you can see with just things. Also you can see Mission GA. So this is my things in here. So when I export, it will be just
So,
exporting from here. Yeah.
okay.
And this is the process for exporting this type of map. Further, you can easily work with ArcMap for creating your map. Right? So this is a process, and there's a lot of spaces in the world. So further, you also try to study from this from website, okay, because there's a lot of space we can find out for the different spaces, and this data set is freely used, so we can easily use it. And further, we are just identify for the suitability habitat analysis, or also potential suitability analysis. So this type of things we also predict, but this type of data we can easily get it from this website. I'll send you all of this code. You also try to check for your own study area and also try to use this code. If further face any problem, then also guide you, no problem. Okay.
Okay.
Okay, thank you. I'll send you this code. I'll also send you the recorded class. You also try to practice.
Okay, sir. So, sir,
Yeah.
this was a class for continuation of the wildlife management, is it?
Would like basically let me check which topic. Okay, so you also check which topic is not clearly finished. You also inform me. Then I'll also try to make the slide about that. Okay. For the last class, which
Okay.
topic, or if you need the more revise any specific topic which you send me,
I,
then also mention, then I also try to revise it also in the last class, no problem.
okay, okay, sir. I think after maybe the last class to finish that the upgrading the grazing map upgrading.
Okay, no
We have
problem, you
left
can
you.
send me that. I also try to make the slide about that.
Okay, after that, then I will tell you some of the topic that maybe you can have a time again to revise, which are very
Okay,
important,
okay,
particularly.
okay, send me that. I
Okay,
also do it, no problem. Thank you. Okay, good.
okay, sir.
Okay, thank
Thank
you.
you.